Today, we're going to tackle one of the strangest and honestly most critical problems in AI. Why do these incredibly powerful models, with all the world's information at their fingertips, just confidently make stuff up?
So let's start with a really simple question. We're going to ask a state-of-the-art AI about Adam, Tom, and Kalai, who's actually one of the researchers behind the paper we're looking at. The question is simple: when's his birthday?
Okay, so on 3 different tries, the model gave 3 totally different and completely confident answers. And here's the best part. All of them were wrong. The paper mentions his birthday is actually in the autumn, so yeah, not even close.
This whole phenomenon has a name. You've probably heard it: hallucination. It's when an AI generates these plausible, realistic-sounding falsehoods and just states them as if they're absolute fact. And this, right here, is a huge reason why we still can't fully trust these tools for really critical tasks.
All right, let's really dive into this. To get why this happens, we need to stop thinking of it as just a simple bug or some kind of glitch. The research we're looking at suggests it's a much deeper, more fundamental behavior that's kind of baked into the very way these models are built.
And this isn't just about obscure facts like someone's birthday. These models can fail at what seems like painfully simple logic. When different powerful AIs were asked how many D's are in the word DeepSeek, they gave answers like 2, 3, and even 7. The right answer is, of course, 1. Just 1.
The real root of this problem goes all the way back to the very first stage of AI training. It's a process called pretraining, and it's where the model first learns the basic patterns of human language and knowledge.
See, at its heart, a language model is just a really sophisticated next word predictor. It's a machine built on statistics. And here's the kicker. The research shows that even if we could give an AI a perfect, flawless library of all human knowledge, the very way it learns by calculating probabilities can actually force it to generate errors.
To see why, let's do what the researchers did and just simplify the problem. Forget about generating whole sentences for a second. What if we just ask the AI a simple yes or no question? Is this statement true or false?
So imagine the AI's job is to be a bouncer at the club of facts. It just stands at the door, sees thousands of true statements go in, sees thousands of false statements get turned away, and its entire job is to learn the secret rule that tells them apart.
But this is where you hit a really fascinating wall. For things like arbitrary facts, birthdays, the titles of dissertations, random trivia, there isn't some deep hidden pattern to learn. They're just facts. There's no secret rule. This makes it statistically impossible for a model to find a pattern that's always right.
And the consequence of this is, well, it's staggering. The research suggests that if just 20% of the facts in its training data show up only one time, the model is pretty much guaranteed to get at least 20% of those facts wrong. Errors aren't just a possibility, they're a statistical inevitability.
Okay, so let's move on to the second stage of training, because if the problem is born during pre-training, it gets actively encouraged and reinforced in the next phase, which is called fine-tuning.
The paper gives us this absolutely perfect analogy for this. Stop thinking of the AI as a librarian. Instead, think of it as a student who is constantly being forced to take exams, and its only goal is to get the highest possible score.
So the most important part is how we grade these AI exams. On almost every major AI benchmark test, a right answer gets you a point. A wrong answer gets you 0 points. And admitting I don't know also gets you 0 points. There is no penalty for guessing.
This creates this really powerful, kind of messed up incentive. If you're an AI trying to max out your score, what's the best strategy? It's to always take a shot. A confident guess might get you a point, but saying, I don't know, guarantees you get nothing. The whole system rewards guessing. And look, this isn't just some theory. The biggest, most influential AI leaderboards, the exact tests that companies use to prove their models are the best, they all use this same guess-friendly grading. We have built an entire ecosystem that basically punishes the AI for admitting when it's uncertain. So if the problem is baked right into the test itself, then the solution isn't just about building a smarter AI. It's about building smarter tests.
And what the researchers propose is actually a really straightforward, what they call a socio-technical solution. Just change the rules of the game. They suggest changing the instructions and the scoring for these benchmarks to actually penalize wrong answers, just like on the SATs or other real-world exams.
By just changing the scoring, you can completely flip the incentives. All of a sudden, making a wild, confident guess becomes a really risky move. And admitting you're not sure, saying, I don't know, becomes a totally valid and sometimes much better strategy.
You're basically making honesty the smart play.
And this leaves us with a final, really provocative thought. What if the path to an AI we can actually trust isn't just about more data or bigger models? What if it's about changing how we measure success, and in doing that, teaching our machines the incredible value of knowing what they don't know?